Welcome back. We're going to continue our discussion on continuity, but today we're going to focus in on some AP style questions that we're going to see in the future. And those are going to be given a piecewise function or some type of function, normally a piecewise function. Can we find constant values, a, b, whatever we want to call them, in order to make a function continuous for any value that we're given? So what does that look like? Well, in example 1 here, we're given a function, x squared, if x is less than or equal to 1, and ax plus b if x is greater than 1. And what the directions are going to tell us to do is to find an a value, so find a to make f of x continuous for all values of a, or for all values of x. So what do we know about this function? We know x squared is a quadratic, and we know all quadratic functions are continuous. So on the left side of this function is continuous. On the right side, ax plus b, if a is a constant, then we know that's going to be the slope of that function, so we know we have a linear function on the right side. So we know by definition again that a linear function is continuous for all values that we plug in. So we want this quadratic and this linear function to meet up at the same point. How do we do that? Well, we know 3 rules of continuity. The first rule of continuity is the value has to exist. So if I look at the value of this function, it's coming from the first part. When I plug in 1, I know the value of 1 is 1. So that tells me that for this function to be continuous, the value is going to have to also equal the limit. So if I look at the left and the right side of this function, it also has to equal 1. Well, we know from the left side it's going to equal 1 because we know that we just found the value and that's the left hand side. So from the left side, we know that's going to be 1. So we're looking at this right side. We know when we plug in 1 for x, we've got to be able to get 1 out. So what's that going to look like? Well, we know that a times 1 plus 2, when we plug that in, has to equal this value in order for these two limits to exist as well. So we know that a times 1 is a plus 2 equals 1, so a has to equal negative 1. So in order for this function to be continuous, it has to be true that a has to equal negative 1. And we can look at this and play around with some of the properties of it. And this is just kind of a little extra. We don't have to write all this out because it's understood here, and most likely going to be a multiple choice question. But we know that the function is x squared if x is less than 1, and negative x plus 2 if x is greater than 1. So if I go through my rules of continuity, f of 1, the value up here again was 1. The limit as x approaches 1, well, from the left side was 1. From the right side, if I plug in 1, I get negative 1 plus 2. That also gives me 1. I guess I should put my f of x there. So my value and my limit, those two values are the same. So it was rule 1, rule 2, rule 3, 1 equaled 1. So we know this is a continuous function. Again, that's kind of just checking our work there. Really, our good final best answer there is a equals negative 1. So we don't necessarily have to do all this checking, but it kind of gives you an idea of what we're looking for. These problems can get progressively more difficult and whatnot. So let's go ahead and run through a couple of them. I have just 4 examples for you today to look at. In example 2, here we're given x if x is less than negative 1, and ax plus 3 if x is greater than or equal to negative 1. Again, we're finding that a value to make this a continuous function. Well, what do we know here? I can't find the actual value of the function because if I plug in negative 1, I get a times negative 1 plus 3. So my value, if I look at step 1, f of negative 1 gives us negative a plus 3. So that doesn't give us a whole lot of information like the last problem did. The limits, however, are going to give us more of what we're looking for. So we know the limit as x goes to -1 from the negative side is -1. So we know the limit as x approaches -1 from the positive side also has to equal -1. So we know that that's a given. So when I plug in -1 into this function, which was up here, we had to get -1 out. So we know that -a plus 3 has to equal -1. Going ahead and solve for a, we can subtract our 3. So -a equals -4. So a is going to equal a +4. So that gives us the value of a in order for this function to be continuous. In example 3, we get a little more difficult and a little more entertaining, in my opinion. Here we're given x plus 1 if x is less than 2, ax plus b if x is between 2 and 3, and 5 if x is greater than 3. So what do we know with this function? Well, if I were to graph out what I have here, if we're less than 2, so here's 2, we have x plus 1. So we're going to have a function that comes up here. It's going to go through, or it's going to touch almost at 3. And then it's going to come down as a linear function. We know on the other side of 3, it's going to be up here at 5. And it's going to be a linear function, or a vertical or a horizontal line there, sorry. So what do we know in between here? We know that ax plus b is in the form of a linear function as well. So I know I've got to connect this with a linear function. How do we do that? Well, we know on the left side we have a point. That point was 2, 3. On the right side, we have this point 3, 5. And I'm going to be able to connect those with a linear function. Well, we can go ahead and think about ax plus b. A is really our slope, and b is our y-intercept. So can I find the slope between these 2 points? Remember, slope, the change in the y's over the change in the x's. So here I have 5 minus 3, which gives me 2 over 3 minus 1. So we have a slope of 2. So I know my a value has to equal 2. Can I find my b value? Well, again, remember, we have at this point y equals 2x plus b. I can use either of my points to find my b value. So if I use 2, 3 to say, I'd have 3 equals 2 times 2, my x value, plus b. So 3 equals 4 plus b, -1 is going to equal b. So now I've got my a and my b value in order for this function to be continuous. And I have one last example to round out our problems for the day. And here we have 5 sine of x over x if x is less than 0, and bx plus, or 2x plus b if x is greater than or equal to 0. So again, if I were to plug in 0, I just get b for my value. That doesn't help me a whole lot. So I got to go into the second rule of continuity, which is the limit. What do I know about the left side of the limit? So the limit, as x approaches 0 from the negative side of this function, I'm looking at 5 sine of x over x. Hopefully we remember our limit rules and definitions. By definition, as x goes to 0 of the sine of x over x is 1. So this limit is going to be 5 times 1, or 5. So I know the right side of this also has to equal 5 when x equals 0. So if I look at the limit, or set this up as x goes to 0 from the positive side, is going to be 2x plus b has to equal 5 as well. So if I plug in 0 for x, I know that 2 times 0 plus b has to equal 5, so b has to equal 5. And that's going to give us these two branches coming together. If the two branches come together and it also equals, I know the value is going to equal the limit. So my b equals 5 is my final answer. Enjoy the AP style questions tonight.